All right, next up is the Hofman elimination. So think back to alcohols, right? If we have an alcohol and want to do elimination reactions to form alkenes, first thing we have to do is turn it into a good leaving group. So you could tosylate it. And then after that, you add in some base to form your alkene. We can do a similar thing with amines here. So if we have our amine, we can make it into a good leaving group by adding excess alkyl halide. So methyl iodide is usually used. And so then we'll go to our quaternary amine right there, which has a positive charge. And that's now turned into a good leaving group. And so then hydroxide can come in and do an E2 elimination, right? Pick up this H, break this carbon-hydrogen bond, and then kick off the leaving group to form our alkene. Except here, instead of using sodium hydroxides most of the time, what you'll find is that instead they use silver oxide, some water, and some heat. The silver oxide just turns into sodium hydroxide in solution and then does the elimination. The weird thing about the eliminations here for the amines is that we're actually going to get the less substituted alkene. So for example, instead of getting the di-substituted alkene here, we're only going to get the mono-substituted alkene. And that basically just has to do with the fact that our leaving group, this methylated amine, is bulky. And so we're going to form the less substituted alkene, right? How a bulky base leads to less substituted alkene, here our leaving group is bulky instead.